So we're one of the sponsors outside, so I'm not going to go into huge amounts of information because we're out there. Right? We're literally just by the door on the left-hand side. And actually, I've got a workshop later on about how to identify I/O problems in your database and what you can do about it. But what I'm going to do at the moment is just talk to you guys a little bit about what the company does. And I've been in databases for 12 years, and I started working with this company about 4 years ago. And because one of the biggest constraints in a database and application is the storage. And there's a certain number of things you can do about that, but sometimes you just have to replace the storage. Now, everyone has probably heard of flash storage. Everyone's got SSDs and laptops and flashes in phones and tablets. It's everywhere, right? It's now also very heavily made its way into the data center. So flash is now a very similar price to enterprise disk drives. So people are actually now replacing disks with flash. So let me just quickly go through the evolution of flash. So Apple first put flash into their iPods, which then came out into the iPhones. Samsung then started fabricating flash, putting it into their phones, etc., etc. It all grew from there. So flash was extremely expensive, and back in 2009, which is when we were the first flash company to take flash and turn it into an enterprise solution, came out. It was really expensive, but it was a performance pain pill. You could fix very, very specific performance problems in applications. And if a telecommunications company has a billing issue, and the storage couldn't fix it, and the DBAs or the application guys couldn't tune that application, people were putting in flash. And the reason why is because response times or latencies are 10 times to 20 times lower than a disk drive. So an average disk drive is about 5 to 10 milliseconds, flash is about 200 microseconds. So instantly, by deploying flash, you've accelerated your applications. And it evolved from there. Around 2012, it started to evolve into the virtualization market. So when VMware started to pick up popularity, and then Hyper-V started to get popular as well, people realized that actually accelerating virtual environments allowed them to increase the amount of density of virtual machines, because that's the whole point of virtualization is how many virtual machines can I get onto every single physical server I've got? The more I get them, the more I save. The constraint of disk drives was the more I scale that, the worse performance gets on the storage. So around 2012, for a couple of years, flash really made its space in there. The price dropped as more phone manufacturers and etc. So Apple started putting them into their MacBooks, and everyone started putting out tablets. It dropped even more. Now, where we are right now, which is the most exciting part of storage, is the price of flash has now moved away from being expensive and only for specific use cases to being adoptable in an economic way as just primary storage. So if you've got multiple terabytes of storage in your data centers running your applications in your databases, you no longer have to buy legacy disk drives again. Flash is actually now the same price. Now, it's a perception that people still have that it's expensive, but it's not. There's a number of technology functionality and software which allows us to bring the price down. That's what flash vendors do. So actually, it's now a very viable solution right now to replace tier 1, tier 2 disk drives. And the future, and this is actually starting to happen now, is with something called 3D NAND flash. And the reason why it's happening is Apple have adopted it into all of their products. Samsung are starting to adopt it into all of their products. And within a couple of years of them doing it, the price drops enough to be able to actually mass produce this stuff. And what we'll see there is what we call the death of enterprise disk. We'll see enterprise tier 1 disk drives literally stop being produced because why would you buy a disk if you can buy flash for cheaper? And that's what's going to happen in the future. And all the analysts, it's not us just saying that, analysts are actually saying this at the moment. And even a lot of disk manufacturers are saying we need to start going more into flash. So what does flash look like in a data center? Right? So that is a data center full of disks, and that's a petabyte of flash. That's 12 units in a rack. I think a rack is a unit. That's about one of these arrays is about that big, and that's a petabyte in 12 units. That's 3 of them. That's gigantic. A petabyte of disk is basically probably about 3 or 4 of those, essentially. And that's all been scaled down into that. And not only is it smaller in form factor, actually it's faster, and then you reduce your costs. You're taking up less space in your data center. Right? It's a massive difference. You know, this is technology that came out 15 years ago, right? Or mass came out 15 years ago. And this is now what the new disk drive is. We always go through waves of innovation. Tape moved to disk. Disk is now moving on. Disk is now moving to flash. This is the next wave of innovation. So the impact of deploying Flash are these. Now the ones that really matter to you guys is performance and cost, right? But not data center cost, because you're DBAs, right? You don't care about how much a data center costs, right? You care about your software licenses. Okay, so firstly, application performance dramatically increases by deploying storage that is 10 to 20 times faster. The average is about 10. So that's 1,000 times improvement in the performance you've got right now. The key thing is that if you can then consolidate databases onto less infrastructure, servers, because now those servers are more performant because they process more data, you can actually reduce your software licenses. So what we're finding is that 80%, and Microsoft don't mind, we work with Microsoft to help people reduce their license count, because it's the only way they're ever going to start adopting newer versions of SQL as it gets more and more expensive per core to buy. So on average, customers are saving about 80% on their software licenses, because every core they've got in their service is now being able to process more data, because it can get the data more faster. So there's a massive cost benefit to that as well, which is now allowing companies to also then move to the latest versions of SQL without the cost impact of moving from, say, socket-based licensing to core-based licensing. And that's one of the things we're doing quite a lot at the moment. So what's driven this is the price. It's simply the price. That's all it is. You know, the benefits have always been there. The benefits have always been there, but the price is now dropping. So our price in 2012 was about $30 a gigabyte. So for every gigabyte you bought, it was $30. That's a ridiculous amount of money. Right? But rich companies that had big problems to fix, the big Fortune 500 companies, bought Violin Flash because it meant that their revenues would go up by billions, because they're now just reasonably straight. Today, we are down to $1 a gigabyte. And actually, the more you buy, the cheaper it gets. It's all about mass buying. So actually, we're selling stuff now at about 50 cents. And you think about this, enterprise disks are about $1 a gigabyte. And that's what's really driven the adoption in mass. And we'll do over the next couple of years in a big way. So when people look at storage, they look at three things, three characteristics, right? Performance, functionality, and price. And price is what you buy it for, and the economics of running that solution as well. And what disk drives have always done is they've given functionality and they've given good price and economics, but never really the performance. It's now become too slow. Remember, the performance of disk hasn't changed in the last 10 years, but we have now moved all towards having devices where we want data in real time. So our requirements of data has changed. So what we did is our solutions tick all of these boxes and to balance it all out. Right? So been around a long time, been 10 years. The current generation solutions, which are 5th generation, launched in February, based on the core of our generation before that. And we've always had a name for record-breaking performance. So we can server vendors who have storage use us to break records with their servers. The key thing though for databases is being able to sustain that performance under load over a period of time. And that's why people have always used us to do benchmarks of their servers, for example, like HP and Dell and all that. So not only is it low latency, that latency is sustained even if you hit the storage really hard. And that's the benefit of Flash. It's fully redundant, it's fully hot swappable, so it's a completely reliant solution which has a full suite of data services to replicate your data across different data centers. So sometimes, especially in SQL Server, when you have, in Oracle it's like different people have a few Oracle databases, which are large. In SQL you have thousands, some people have hundreds of thousands. Sometimes replicating those can be a bit of an issue at the SQL level, so they'll do it at the storage level. So no one's going to deploy Flash if you can't replicate your data. So there's a full suite of replication, various different modes of replication as well. But the key thing is simplicity. Right? I remember as a DBA needing to get storage from a storage guy and say, what RAID groups do you want? Okay, is it logs? You need to have that RAID group. Is data? It needs to be that RAID group. It would take 6 months before I get any storage, and I needed it 6 months ago. And it's because disk drives are disk arrays are complicated. Where do you put your data? So because disks are unreliable, it needs to be spread everywhere. It's different RAID groups. So Flash simplifies all of that. So if everything is fast, everything is evenly distributed across Flash anyway, and it's all parallel random I/O performance, you no longer need to worry about stuff like that. So actually deploying some extra storage for your databases is a matter of 3 clicks and a GUI. Click, 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 you're done. It's presented to the server. You don't have to worry about RAID, because it's all one RAID. You don't have to worry about stuff like that. So actually it simplifies your task as DBAs to build highly performing databases as well. You don't have to worry about multiple directories where things are sitting in different directories for contention and stuff like that. So it's simple. And for storage guys, there is nothing to manage. It just runs straight out of the box. Now, architecturally, we're very different. So everyone's heard of solid state drives, right? A solid state drive is basically a hard drive with the moving bit taken out and the flash chip put in there. That's all it is, right? But the mechanics of that SSD is still like a disk drive. The software was still designed 15 years ago to manage disks. But what they've done is to make it easier for everyone to adopt in laptops and PCs, is they took that architecture and just took the moving part out. The problem is there's limitations to that. I'll show you what some of even the guys that make solid state drives are now saying. But we took a different approach. We said, okay, if you've got really fast technology, why would you constrain that technology by putting it into a disk drive? So you can get slightly better latency than a disk drive, but you're not going to get the best. So we take the raw flash from Toshiba. We build those modules on the end there, which look like DRAM, like DIMMs that you put into your server, slightly bigger version of them. And then we package that up into what is a custom designed hardware and software infrastructure. So it's a completely integrated solution all the way from the software to the hardware. So if that was a solid state drive, the solid state drive would be made by Samsung, who have their own firmware. The other components would be made by someone else. The software would be open source, most likely, and I'd be tweaking it. But I can't control the flash. It's Samsung's flash. So it will do what it can do when it wants to do it. I have no control over that. So I have to reverse engineer, blah, 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 blah. It's quite a lot of work. So actually, by doing it this way, we control every single level of flash. We can deliver that parallel performance and so forth. But the key thing here is that it's a completely tightly integrated solution. That's the key thing. Now, people said we were nuts for doing this, because it's actually R&D-wise, it's expensive, right? You need a lot of researchers and engineers to build this stuff. Whereas otherwise you just buy SSDs from Samsung, and it's their cost. But actually what's happening is now people are realising the limitations of solid-state drives, and they're now trying to do this. And we did this 10 years ago. So actually we're now reaping the rewards of having gone through that benefit, that cost 10 years ago. But it also means that we get that performance, but it also means that we get the price points as well, because we're only buying the flash from someone, and everything else is designed by us. And this is what allows us to get to that performance and density levels, and the innovations going forward. So the reason why people so that's some of the reasons we don't use solid state drives. One of them is something called garbage collection, right? So without going into too much detail, in a disk drive, if you delete data, it doesn't actually delete the data from the disk. What it does is it just hides it, right? When you write new data, it just overwrites that data again. That's all it does. So actually, that's why you've got recovery software, which can recover data that's been deleted from the disk drive. Because actually, all they've done is they've just hidden it. It's still there. That's why if you want to do it properly, securely, you've got to write over it millions of times, loads and loads and loads of times, and burn it, right? Flash doesn't work like that. In Flash, you always have to write to an empty place where data has never been written. That means when you delete data, the SSD or the flash device has to physically delete that data before it can be available to new data. And they call it garbage collection. At some point, it's a process that goes through the flash device and clears up all the old deleted data. Now, what happens when that occurs in a single solid-state drive, it blocks any writes until that process is finished. You can read from it, but you can't write to it, because you've got nowhere to write to, because it's now clearing up. And it usually does that when there's hardly any space left. You've got like nothing left, and it goes through this process. Now, the latency, a delete takes 10 milliseconds in Flash. It's a big process. So if you can't write to that solid-state drive anymore, your latency has gone from 200 microseconds to 10 plus milliseconds, which is actually slower than a disk drive. It's called garbage collection. So if you don't manage that process properly, you can end up with big spikes in your response times, going from really fast to really, really slow to really fast to really slow. And that's the problem with solid-state drives, because it's a disk with flash chip inside it instead of a disk. That's what it is, right? So it's treating it like a disk drive. So what SSD vendors are now starting to do is they're now starting to do what we do, is basically design modules that and Apple started doing that. There's no solid state drives in there, they're actually flash chips. And they've designed their own controller to manage that chip. And the reason why is they don't want these, don't want laptops in the, I should read it's Microsoft, so the Surface Pro, right, uses flash. What they don't want is you to be writing and saving a document and it's going for a garbage collection, you can't write for like ages. That's what they don't want to do, right? So so SSD vendors are now also saying that they can't carry on doing what they've been doing for the last few years. They need to change the architecture. So here's an example. Micron, who are the third largest producer of flash chips and also one of the largest producers of solid state drives. I didn't know every single BMW has a Micron flash drive in it to run cars. These guys are huge. I didn't realise how big they were. And they've now also said that solid state drives, treating flash as a disk drive, solid state drive, has outlived its usefulness. So all of their solid state drives are now going to move towards module drive, what we're doing, to be integrated into devices like laptops and so forth. You've got analysts as well that are basically saying, actually EMC, in one of the articles, said actually the way they do it is wrong, they're going to use the way we do it, which is the EMC, which is a competitor, funny enough. But analysts, so many people are now just saying it's even in laptops, solid state drives are no good, not good enough. Because we're now putting too much pressure on our own consumer devices that they have to go down a different route now, basically. And that's why we've always never used solid state drives. And so we're ahead of that curve. So if you buy a solid state drive array now from another vendor, that array will be obsolete in probably about a year or two's time. And that vendor will have bought out something completely different. And actually a lot of them are doing that. So, and I always like to end with this, I love this quote, but insanity is basically doing the same thing over and over again, expecting different results. So if you're sitting there as a DBA, adding indexes to a database to improve the performance and tuning code, it's not getting you anywhere. There's a reason why it's not getting you anywhere. It's because the infrastructure underneath it is not allowing you to get anywhere. So you need to try something different. And if you can go to your business and say, look, you can deploy this, which is like 10 times faster than what you've got right now. It's not going to cost you any more to buy, but it's going to improve the performance of your systems, but also save you cost in your data. What business is going to say no? Right? But it's also going to make, as a DBA, and this is why I joined the company, because as a DBA I was getting frustrated that whatever I did was 30%, 50%, and the storage was always then the bottleneck. So I joined these guys 4 years ago to help push that into the market, say, look, there is an option, there's another option. So think differently. Don't keep doing the same thing expecting different results. And Flash is now accessible to the majority as a price point to get that benefit. And that's it. Try to keep it as short as possible. If you've got any questions, I'm outside, just on the left-hand side. As I said, I do have a workshop, which actually, instead of going into us, it's not sales pitch. It's more just about how do you actually know you've got an I/O bottleneck, and what do you actually do about it? What's the different options available? How do you use perfmon to check that and stuff like that? So if you're interested, that's at 125 from somewhere. I don't know which room it's in. Right, thank you very much. It's lunchtime.
Yay!